All right, looks like things have stabilized a little bit, so we'll go ahead and get started. First off, thanks again for being here with us today. My name is Michael Irwin. I'm part of the DevRel team here at Docker. I'm usually based out of the East Coast of the United States in the state of Virginia, but right now I'm coming to you from Berlin, where we're here for the We Are Developers Conference, and excited to be here with you. And I'll pass it over to Christian, who will introduce himself as well.
Hey everyone, I'm Christian here. I'm a senior principal engineer at Docker, part of the Docker Scout team, and I'm usually in Germany, but I'm up in the mountains in Austria right now, which is the funny background. So I'm happy to be here today and talk to everyone.
Awesome. And so, yeah, we're both traveling, and it makes this a little more fun logistically, but again, we're excited to be here with you today. So quick agenda of how we're going to go throughout this. We're going to start off actually talking a little bit of some of the results that we've learned from the Stack Overflow developer survey. So we'll dive into some of that and then use that to kind of set the stage for Docker Scout, what each of you are here for as well. And so we'll talk about Scout, and then we will have some time for demo, and then we'll wrap up with Q&A at the end as well too. So feel free to start putting questions in as you start thinking about it. We'll wait to address them until the end. But again, you're welcome to add questions at any point in time. So with that, let's just jump right in. For those that aren't familiar, the Stack Overflow developer survey was released just a couple of weeks ago. And those that aren't familiar with the Stack Overflow developer survey, it's a survey that they've been running now for 13 years. And this year they had almost 90,000 developers participate in it, which is a pretty staggering number, and is actually a 20% increase from the previous year. This developer survey represents developers from 185 countries across the globe. And Stack Overflow basically asks a ton of questions and then takes all that data and provides insights and publishes a report to the rest of the world to consume and to use. And so we've been looking at a lot of the results and a lot of the insights that were gathered through that survey, and we want to share a couple of them with you. First thing is, this year's developer survey actually introduced a new category, and that category was of AI. We've seen a lot of a rise in AI and machine learning, especially in the last year. And so this developer survey this year they actually broke the AI report into two different areas, one being sentiment and usage, and then the second being developer tools. And while we didn't put all the stats on the slide here, some interesting things to call out were that developers are actually starting to use these tools quite a bit in their development. Now, there's still a little bit of hesitation on how accurate or do they completely trust the results that they're giving. But we're starting to see more and more usage of it. And developers are actually starting to, even those that are on the fence are starting to project that they might start using it pretty soon. To us, that also means that, one, this is an interesting space to be looking in, but also two, developers are wanting to have more assistance and more tools to help them accomplish the things that they want to do and do it more quickly. And we'll talk more about that in a little bit. Secondly, the developer survey dives a lot into the popular languages that are being used. And we've fully recognized there are only 90,000 developers out of the millions that are out there. So there's a chance for selection bias. But over the last 2 years, the web technologies have been the leaders. But it's interesting to watch the trends of what's becoming more popular, what are folks looking at. And so, in fact, one of those that we saw the most admired language, Rust, 80% of people have considered that they want to try it again next year. And we've seen that number increase over the years as well. And another interesting fact as well too has been just the trend of most popular operating system and Windows now being up to 60% of developers prefer to use it both personally and professionally. So again, it's been interesting to see the shifts and the trends and the changes over the last couple of years. One of the things that we also wanted to recognize and thank everybody for is that Docker was rated both the #1 most desired and the #1 most used developer tool. And for us, that is incredibly humbling. We first want to thank you, and Scott Johnson, our CEO, has some words to say, and I'll have that on the next slide here as well too. But again, we use this as an internal first recognition, but then a constant reminder that we need to continue evolving and continue doing better. Scott Johnson, again, our CEO, wrote a blog post shortly after the Stack Overflow developer survey was released. And a couple of the words that he shared are as follows. As a company obsessed with serving developers, we deeply appreciate this ongoing recognition and support. While we're pleased with this recognition, for us, it means we cannot slow down. We need to go even faster in our effort to serve developers. And then from there, he dived into 3 particular areas that we're focusing on as a company on how we can help developers be more successful. And specifically, the first thing is on speed. And we saw a little bit, again, of this again with the AI talk, but developers want to have more tools and more capabilities to focus on their code and deliver code faster, deliver features, fix bugs, et cetera. And they just want to do it early and often. Developers want speed. Secondly, developers, we saw a lot of uptick in the security space as well. As developers are building more applications using open source libraries and leveraging other packages and libraries, they want to be able to keep up with them, but also be told how to fix problems when they come up in non-intrusive ways. Developers want, again, kind of going back to speed, how can we catch and find issues earlier in the development lifecycle rather than waiting for a CI build that may be 30 minutes later, or even a production scanning system that catches things maybe even days later in production. So how can we help developers know about these issues earlier, remediate and respond to them much more quickly? And finally, again, developers want choice. They want to be able to use the right tool for the job when it makes sense, and have the flexibility to choose, again, for this particular application, I may use language X, but for another one, I may use language Y, or be able to swap out libraries. So again, how do we as Docker help support developers with speed, security, and choice? Now, there's obviously lots of ways that we can do that, and there's lots of particular features that we've been working on recently that we can dive into. But specifically today, we're going to be talking about Docker Scout. And in order to really understand Scout, we actually need to kind of take a step back and talk about something that we call the secure supply chain. Okay, and this is a term that gets thrown out quite a bit. And so what I want to do is actually kind of level set and talk about what is it that we mean when we talk about the secure supply chain. Now, the analogy that I'm going to use here will probably resonate with many of you. I'm actually going to talk about basically coffee and how coffee beans are created and how we can know the source of them and everything. I myself am not a coffee drinker, so it's kind of fun that, yeah, I'm using this analogy. But hopefully it resonates with you, and you can still understand and pull out the principles that come throughout this. Okay, so imagine that I want to make some coffee. I want to be the best. I want to use the best coffee that's available to me so that I can get the best results and it helped me do my work. Now, in order to do that, there's a lot of inputs that go into the process. Okay, so I obviously need a good machine that can create it. I want to make sure that I've got a good source of water that's filtered, that's not introducing impurities itself. But then I also need a good set of beans. And I need to know that those beans are good, and that they were also sourced from good locations. Now, I can also decide, I can try out lots of different beans, or I can go to beans that have a certified logo on it, and that logo means a lot to me. In fact, if we dive into that a little bit, that logo tells me quite a few things. One, it tells me where the beans came from. It tells me that they've been grown sustainably, that the farmers are using good practices, environmental sustainability, et cetera. It's telling me that proper labor practices are being applied and that the farmers are being paid a good price. It just tells me a lot of information about that. Now, at the end of the day, if I really wanted to, I could have gone out and done all that research myself, and I could have gone and visited the farms and gathered all this information myself. But because somebody else has done this, now I can trust that, and I know that whenever I see beans with this logo, I know a lot of these other practices that have been applied. And this attestation, again, because it's a certifying body, tells me that these beans can be trusted. Okay, and so without all of their effort that they do and all the research and digging into things, that little logo is meaningless. Okay, so how does this apply in the software space? Well, in many ways, we're doing much the same thing. We're gathering information, we're gathering libraries, and we have lots of questions to ask. Okay, where did this library come from? Who's writing it? What build processes did they use? And we have to answer a lot of these questions. And then once we've got the code, we're creating our own artifacts as well. Of course, at Docker, we're thinking a lot about containers and images. So we're thinking about the final image, the final box we create. How can we assert and attest to the things that are in that image to say, here are the libraries, here are the packages, here's how it was built. And then how can we move that image around and help transfer that metadata in trusted and reliable ways. So there's a lot that goes into, again, this entire supply chain of software, because again, we're not always creating every line of code that goes into our software. How do we get the full picture of things? And then more importantly, if things don't go right or new vulnerabilities are introduced, how do we resolve? How do we remediate as quickly as possible? In fact, if we look at the supply chain, there's lots of opportunities for injections, and we've seen this over the last couple of years as many of the major news hitting hacks that have occurred. Many of them aren't in the final production systems, but are starting to move leftward as well, of compromising CI systems or injecting code. There's lots of different scenarios there, but the attacks are getting more complicated. And so how can we know that our code hasn't been compromised, that things haven't been manipulated, or when we push our container images that they're not being manipulated, maybe sitting at rest? How do we detect that? There's just, again, so many different things that we have to look at across the entire software development lifecycle in order to know that our software is safe. And really, there's no 100% way to know that it's always going to be safe. So when new vulnerabilities are discovered or new issues are found, how can we remediate as quickly as possible afterwards? Okay. So to help answer this, there's actually three different components that go into this. The first off is basically what's in the box, what's actually in the software artifact itself. And the way that we answer this is through what's called a software bill of materials. And the software bill of materials at the end of the day is a manifest that describes, here's everything that's in our case, in a container image. Here are all the installed packages. Here are all the libraries, NPM libraries or Java libraries or whatever it might be. Here's everything that's in the box. Okay. Once I know what's in the box, then it raises the question of, well, how did we build the box? Where did all this come from? And that's where provenance and attestations come into play, where it gives a history of how did we produce this image. So for example, if I had a Java application, I need to know, my final image may just be a JRE in the final jar, but what build tools did I use to actually produce that? If I'm using Maven, what Maven plugins were used, et cetera. And so I need to know a little bit more of the history of how this software was actually created. And that's where provenance attestations come in that can give me that additional insight, even if it's not actually in the final container image itself. And then the final question is, how can we verify these different manifests? How do we know that nothing's been compromised along the way? How do I know that I didn't push an image to a registry and maybe it was compromised at rest, or somebody else push a manipulated image? And that's where signing comes in, where I can know, I can cryptographically sign these manifests and the images and everything that goes along with it. And so as we move the image and promote it between our different environments and registries and whatnot, I can cryptographically know that this was produced by my CI system and it hasn't been compromised anywhere along the rest of my supply chain. And that's hugely valuable. Now, at the end of the day, many of these components have existed for a while. For example, being able to build a software bill of materials has been in the Docker CLI for a while now with the Docker SBOM command. And some of these other are newer features, but there's a lot of individual components that have to be put together in order to make it all work. And that's exactly where Docker Scout comes in. So with this, I'm going to pass off to Christian, who's going to explain a little bit of Docker Scout in more detail, but then gives a demo of it in action.
Yeah, thanks, Michael. That was really interesting. So Docker Scout is really like picking up where Michael left us, like mentioning SBOMs and provenance attestations and signatures. Docker Scout is really kind of like three things, and I want to talk about each of those before going into a demo. So first of all, within the Docker Scout initiative, we really want to supply the required supply chain metadata, provenance, SBOM, signatures of those, signatures of images, as part of our trusted content initiatives. So Docker official images, Docker verified publishers, and Docker sponsored open source. And that's really kind of to lay the foundation of a very kind of trustworthy and secure supply chain. because remember, your supply chain starts all the way to the left with the coffee beans and kind of like as they move through the supply chain to your coffee machine. Following this analogy, like the Docker base images that everyone is using, like millions of developers are consuming Docker official images, we need to kind of like level up, and we need to provide these supply chain metadata to kind of like make these things really kind of like the entry point of your supply chain. And on top of that, the supply chain doesn't end in the inner loop, right? It goes all the way to production. So there are many systems along the way of the container images that start to create data, like things like your CI system, your test coverage, your deployment tool, deploying things into Kubernetes, images coming up and getting undeployed in Kubernetes, your APM solution. All these things start to emit events along the way, along the life cycle of your container image. And with Docker Scout, we will have integrations into all of those systems, and we will take the data and kind of build up a correlated graph of data. And that's kind of what we call system of record. So making it possible for you to, at any time, create the proof and evidence required for your stakeholders to prove that your supply chain kind of like was designed in a certain way, had certain qualities, and so on and so forth. And on top of all of that, we will be offering and are already offering kind of what we call policy evaluation. So there are a lot of policy engines in the market. A lot of those policy engines really focus at the very end of your supply chain. So can something go into production or not? What we want to do, really strictly following what SJ had in his quote at the very beginning, being developer obsessed. So moving this to the left all the way into the inner loop, allowing developers to use the same policy that ultimately gets applied across your whole supply chain, and to continuously ratchet forward your security posture, but also your overall delivery, and making it more efficient, more automated, and so on. So that's really kind of like an exciting area within Docker Scout, in which we will be talking a lot more in the not too distant future. With that, I want to kind of jump into a quick demo of Docker Scout. So Michael, if you let me take over the screen share. Right, so this is a little demo project that we use to kind of demo Docker Scout. It's a Node project, and what I want to do really quickly is I want to pick up somewhere that, like Michael mentioned, like the Docker CLI is able to create SBOMs and provenance attestations. And I want to kind of like use this sample project to show you how you can use this today, and then how you could put the data that Docker build is producing to action using Docker Scout. So let's just open up the Docker file really quickly here, so that this is a very simple Docker file, not a multi-stage, a single stage Docker file, just putting in some npm dependencies, running npm install, and then pretty much that's it. So if we go to the CLI here and do Docker build x build, the trick really that which is everything that you need to do to create SBOMs and provenance attestations, is really to include these two parameters. And while I do this, we'll see the build running now. You'll see a part here where it says generating SBOM. So really embedded in your build, you get like, during your build, you get an SBOM, you get a provenance attestation. Of course, the provenance attestation on my laptop isn't as strong as you running this on, let's say, GitHub Actions, for example, where we can capture a lot more about the CI environment. Now we see that the attestations have been pushed. And now what does this mean? Like, we can use Docker Scout now to run a simple command against the image that I just pushed to Docker Hub, which is our CVE's image. And you can see that if I scroll up quickly, you see that we have obtained the provenance and SBOM from these set attestations that we created during Docker build. And you can see that the whole command was really quick to execute, right? There is no post-build indexing, no post-build security or vulnerability scanning happening. And you can see like what these attestations are really useful for. For example, they have captured the Git commit and commit shard repository that they were being built from. They have captured the base image that was used, Alpine 314. So all the things that make it really important to kind of to record as facts in your system of record in your for your supply chain security in these attestations. And then of course we can go further down and we see For example, here we see that libSSL is introduced by the first line in my Docker file, which is my from statement, and it's affected by all these vulnerabilities, right? If we go back to our Docker file quickly, you see the first one is actually my from line. So this is our provenance attestations in action, which the provenance attestation gives us access to the Docker file and to the source mapping between image layers and instructions in the Docker file. So really like putting all this metadata to good use. And now I want to be an application developer and really kind of start to focus on what can I do in my inner loop to improve the quality of this image, to improve the security of this image. And now what I did now is I just want to exclude all the vulnerabilities coming from my base image. And quickly I narrowed it down to like 2 vulnerabilities that are both coming out of my NPM layer. So I can see here NPM Express is vulnerable to some really interesting vulnerability with a high severity. And Scout is suggesting me to upgrade to 4.17.3. So let me go into my project. And I see exactly which layer is introducing this. So I can see that I'm running npm install. So that probably means it's in my package.json or yarn file. I can go in here and update this and super quickly or quick run my build again. And this time I'm just going to be doing this locally. And you see, I can now run the same command again, but this time against the locally built image. And you see that hopefully we'll see that all our npm ones are gone. Let's try this. So let's focus on only package type npm. Of course, there's a typo as it is with every demo. And you see there are no npm vulnerabilities anymore. Of course, there are quite a few others in here. And knowing Michael, he likes beautiful UI. So let me jump over to Docker Desktop, preempting a question that he's likely going to ask. So here's our image that we just built. Let me make this a bit bigger. And you can see kind of like I get a nice little layer view here. And what I really want to show you is there are these base image recommendations here. So we know from looking at our Docker file that we're using 3.14. Docker Desktop as the CLI, as Docker Hub, everywhere we have Docker Scout can tell us now that actually, you know what, by upgrading to 3.18, I'm going to be fixing all these vulnerabilities coming out of my base image. Well, that's an easy fix for me to do as a developer. So let's quickly do this. And let's go back to our build command here. Going back here. And you see everything's green. So this is me as a developer, strictly in the inner loop, using kind of like Docker Scout to fix application level vulnerabilities, base image vulnerabilities, using kind of guided remediation. Another thing that I really want to quickly show you is something that we call comparing local work or pull request work to what's currently running in production. So being a developer, I really care about like how is my work affecting or changing what to compare to what's currently running in production. So I can use Docker Scout to simply say Docker Scout compare. And I can use my local fix image and say, I want to compare this to something called a prod stream. And that stream is just a logical name for our production environment. I can run this now. And what this will do is it will query the Scout system of record and will bring down the image that's currently running in our demo Kubernetes cluster and compare my local SBOM, my local vulnerability findings against the one from the image running in production. So I can see here now, this is our image in production. You can see the Git provenance, you can see its vulnerabilities, and this is my image locally on my system. There's a little link here that takes me to scout.docker.com, which is our kind of like, view into data, into images in registry. So if you want the same kind of functionality with recommended fixes, not just locally, but across your teams, across your organization, you have a means of doing that with scout.docker.com. But this, again, gives you a really quick overview of your local work, analyzed image here, the local fix tag that I've built compared to what's currently running in production. You see the labels changing, you see the environments. There were no changes here. And you can see all the image package updates, version changes, uninstalls. You can see how a particular BusyBox upgrade fixed all these vulnerabilities, and so on and so forth. And all of this really kind of to give developers the tools needed, the visibility needed in their inner loop to really quickly and efficiently make changes. All going back to what Michael said in the beginning, Stack Overflow survey, increase the velocity and speed of developers, and while doing so, increase also the security footprint and stance of an entire organization. Michael, that was my demo. Handing back over to you.
Yeah, fantastic.
Some
So
closing remarks.
yeah, I'll just close things off here. So first off, I've got the link up here to learn more. Check out the product page at docker.com/product/docker-scout. Also, we will be sending a survey out afterwards to get additional information. And once you complete that survey, it'll also send you additional information about Scout as well too. So please fill out the survey. Give us additional information on first off, did you like this session? What did you learn, et cetera? And then go from there as well too. So at this point, we have received a couple questions. I'll go ahead and drop my share as well. First question is, how do people get started with Scout today if they want to?
Yeah, that's a good question. So for those of you who are using Docker Desktop, it does come with Docker Desktop, so you can just use it from the CLI. So just start typing Docker Scout --help, or start using the image layer detail view within Docker Desktop. That's a good way of getting started. And there's also a repository where you can install the CLI plugin for those environments that are not Docker Desktop compatible. For example, like your CI server or any other kind of environment where you just install the Docker CLI from a package repository, for example.
Fantastic. All right, so another question I see it kind of scattered, or at least the theme is scattered across a couple others, and it's one we hear often. How does Scout kind of compare to like traditional just scanning type tools? What's different about this?
Right. I mean, that is so I think fundamentally we don't scan, right? We use the metadata that is produced by your build, by your Docker build. So you produce and ship an SBOM. Hopefully that SBOM is signed, and then we use the SBOM to constantly match this against kind of like our vulnerability data, and that vulnerability data is sourced from like approximately 20 advisory sources. So for all various ecosystems, Debian, Ubuntu, GitHub, GitLab, all the kind of trustworthy providers of advisory metadata we use, and we constantly overlay this package and advisory data. And if we do find a vulnerability, it's going to be immediately reflected on Docker Desktop in the CLI and on scout.docker.com. So there's no re-indexing, there is no kind of batch process happening. It's all stored in the big system of record that I mentioned in the beginning. So the data is always at any time, it's always current and up to date.
Yeah, so as a specific example of that too. So for example, the Log4Shell that hit many of us pretty hard not that long ago actually, with the SBOMs and our container images on Docker Scout, for example. Christian showed off just a little bit of scout.docker.com, but one of the functionality, one of the functions of that is you can go into a vulnerabilities tab and basically say, I want to see all images that are affected by this vulnerability. And so, yeah, you're not having to spend days having to go rescan all of your images. You just get that information.
Yeah, and it's also, it's like under all of this, there's an SBOM, right? There's also a package search. So like, remember there was an OpenSSL pre-announce a couple of months ago where they said next week on Tuesday, we're going to announce a serious vulnerability. No one knew what would be going down on Tuesday. So everyone was kind of like scrambling to find out where are they using OpenSSL, and then with our package search, that's totally possible as well. So you can know ahead of time, even before these vulnerabilities get disclosed.
Fantastic. All right. Unfortunately, we're out of time right now, and we see more questions. So again, feel free to we'll take the questions, and there will through the follow-up survey. We'll we'll find opportunities and ways to help answer some of these questions as well too. Folks have been asking about a recording that will be shared with you within the next couple of days as well too. All the Zoom webinars are automatically recorded, so that will be shared with you as well too. And again, we thank you for your time and thanks for being here with us today. Thanks all.
Thank you. Bye-bye.